so much. Hello, everyone. I am so glad to be here. I think it's 5th time I'm in the VueJS Amsterdam. Every time I'm saying all the speakers and attendees, it's like a ceremony every year. For all of us, the thing that started as VueJS, the mastermind behind it, Ivan Yu, that made Vue an amazing ecosystem with Vite and Nuxt and whole other things that started. We became a whole bigger ecosystem. We became a community of people. And today I'm here to talk to you about some updates about Nitro. Before, how many of you used Nitro before or are using Nitro? Okay, I can counting. How many of you are using Nuxt or familiar with Nuxt? Oh, much more. So the interesting thing is that, if you're using Nuxt, you're already using Nitro for most part of the server. Nitro, I will explain it more about it. Before, I'm Pooya Parsa, by the way. I'm creator of an ecosystem called unJS. We will a little bit talk more about it, and Nitro. And I'm a core team member of Nuxt. You can follow me on social media. By the way, huge shout out to Blue Sky. If you already haven't joined, I really suggest you to join. Almost most of the tech community from the open source moved away from other social media to the Blue Sky. So if you are there, just drop a message. And it's huge. There are also some lists. You can follow amazing people inside Blue Sky, so you don't have to just lose your followings list. That's amazing. So Nitro is a universal server engine. When we was developing, I think 2 years ago or 3 years ago and working on Nuxt version 3, we figured out if we want to go really full stack, if we want to have a real server that's a first-class server for a full-stack server for application, not like other frameworks that they have small server functions, we need to make a layer, and we need to test this layer, and we need to make sure that this layer works exactly the same wherever you deploy it. And that's what exactly we made. We made a framework and a subset of utilities behind it that make sure of it, that when you are using Nuxt, you can deploy it anywhere you want, exactly the same code. You probably don't even notice Nitro in many cases, and it just works. This is a really good representation in the Nuxt documentation, how Nitro fits in. Nitro is like the server engine inside Nuxt. So when you start a Nuxt application, you have a client-side part, you have SSR rendering, and this SSR rendering is happening in the server, whether you are in the development mode or deploying to production. If you have server roles or you don't have them, there is always a server in dev or production. And Nitro is that server. And inside Nitro, we have a framework called H3, which stands for HTTP. Is a substitute for frameworks like Express or Connect or other meta frameworks. And it serves as a utility kit for making API routes. Nitro has much more. With Nitro, inside Nuxt or without Nuxt, you can have API routes. You can have first-class support for WebSockets. That's probably in many examples, you can see how WebSockets work perfectly fine and super fast. This is because we made the abstraction. There is a built-in storage layer inside Nitro that you can use it to store simple values. There is a built-in SQL layer that without even using an ORM. If you have Nuxt, you already have SQL built in. You just have to enable one flag, and you have SQL for your full-stack application. There is built-in caching using key value storage. There is built-in route rules engine that you can use to add rules for caching, for proxying, for redirects, for everything they can imagine. And there is a built-in task runner and so many more features. Also, with Nuxt or Nitro or any other Nitro-powered framework, you can deploy your application to more than 20 deployment presets. They involve different runtimes, so whether it's Node, Bond, Dino, or cloud providers. It could be Node.js providers. It could be serverless providers. It could be edge runtimes like Cloudflare Workers or Dino Deploy. It doesn't matter. It just works. You can learn more about Nitro from its official documentation about how you can make API routes, what the features are available, and the future things that are coming soon. Nitro it's in a very good state. It has currently more than $2.9 million downloads. In past 2 years, it's almost tripled or doubled. It's amazing, and I will show you later why. It's because we took the same philosophy of Vue, not keeping things for ourselves. Nitro could be just part of Nuxt and keep it for ourselves. Thanks today, we have so many more meta frameworks that joined, and that's what it made it happy. And these numbers to grow. And this growth is not only to help others, it's also helping back for Nuxt users, because if you have more users, if you have more feedback, if you have more real case scenarios, we can improve things together in one place. We have more than 290 contributors to Nitro, more than 25 deployment presets. With many of them, we have official supporting channels. We are closely working with these deployment providers to make sure that Nitro, while it's completely open, while it's completely agnostic, it's also in part of its standards with these deployment providers. So when you deploy to them, you can make sure that it's not a hacky solution. We are always in contact with them. Almost every week I have meetings with Clover team, for example. So we make sure everything that we provide is first-class supported. And the amazing thing which happens because of opening is that it's not for Nuxt just for Nuxt. You can use Nitro standalone as a standalone server. You can use it with Nuxt. You can use it with Analog, Solid.js, TanStack Start, McFly, and one more framework from the React side is joining soon. So you see, it's even though that the React ecosystem seems to be far away, isolated from Vue, just being open, this is how we can come everything closer together. So we made something like Vite or Nitro that everyone can benefit and everyone can contribute to. The other thing is the OnJS ecosystem. OnJS is the other thing that we made alongside making and developing Nuxt, was that every time we needed a solution, every time there was something that we needed and it wasn't in NPM or it was not a good solution for it, we was thinking, okay, why not? Why we don't make a better solution for it? And it happens for most of the frameworks, to be honest. You have a need, you add a feature inside your repo. But we thought, what if we could just extract this as reusable solutions? Just like Linux philosophy. We have tools that do one job, do it perfect, do it modern, and we can iterate from them. We can test them. We can isolate, design them, and improve them, and make sure they are perfect solution. Then we replace them. One of the examples is Xsolve that you saw in Daniel's presentation, how we could make the startup time 3 times faster, is that of this. We made a solution to replace the previous one. We tested it a lot of times, and then we quickly replaced it across ecosystem. Why? Because it was one simple single tool. We could make sure that it's perfect. It's enormous, to be honest. I was never imagining this would happen. And every year, I just run a script to count the total downloads. Just for the scale of it, you could see how much downloads Nuxt has. You can compare it to Vue. It's 750 million is something I could never imagine that would happen for ecosystem. It's a lot of packages. We have 56 packages I was counting. Some of them we deprecate, some of them will be replaced. But in total, that's a lot of efforts. And I think it's really worth it. It was really worth that we extracted our solutions for everyone. There are really amazing examples. Some frameworks seem to be competitors of Nuxt, but we are not in reality. For example, we made storage layer for Nitro for key value storage. It's called Honest Storage. It's powering Nuxt and Nitro. But Astro team was also considering, OK, we want to support sessions, and we need to store sessions somewhere. And they said, we want to make sure that it's compatible with every deployment provider. What we do? They saw Honest Storage, and they adopted it. And we worked with them closely for weeks. So we make sure it's compatible, and they just used it. Why not? Other example that is going on is the WebSocket layer. We make sure, because there is literally no standards for the WebSockets in the servers other than Node.js, we had to make sure that we have an adapter-based system. But we made it isolated. We made a library called CrossWS, which is cross-platform WebSockets. We saw it in action last year, how fast it is. And then SvelteKit team was considering, OK, we also want the same. We all have our own adapter system. What we do? OK, no problems. There is a solution. And yeah, surprisingly, also, Spellkit is considering to adopt it. There is an ongoing pull request to adopt it, and it's just amazing. It's feeling good that we are sharing this with others. There are also a little bit older examples like GT, which is still in use because there is still no stable TypeScript for runtime support. There are differences between CGS and ESM. I think 5 or 6 years ago, I made GT. I was just using it as a replacement for an old package. I was never imagining it has $106 million per month. It's used by ESLint, by Tailwind CSS, by countless of packages. So this is something I'm really proud that we are making, and we are making sure that whatever we make is stable. It's a strong foundation for everyone. Coming back to Nitro. Nitro version 2.11 just released last week. We spent a lot of time to, instead of releasing Nitro version 3, to put a priority to just have a hype for marketing. We spent time to make a stable release for Nitro 2.11, backporting as much as possible. So if you are using Nux today, you have to have these improvements just today, not next month, not requiring you to make a major upgrade and do all the migration. We backported a lot. One of the first things was error pages. It was long overdue, so it's now much more beautiful. You can see stack traces, whether it's your Nux server application or server routes or syntax error. They're all unified in one error page. We improved the dev server, so it's much more stable. The reloads are faster and smoother, and we covered a lot of edge cases. There is built-in SQLite support. If you don't heard about it, Node.js also itself has a built-in SQLite experimental feature, and Dino announced it as the same compatibility package. We made the resolutions much faster. That's the thing you saw for Nux as well. Xsolve is the new resolver that we internally use. We identified so many common patterns that we had to make them faster. We extracted the implementation from upstream Node.js. We put it in a standalone package. We made it perfect, and we adopted it everywhere. One of the huge big things was Node.js compatibility for Edge and Dino version 2. Yes, Nitro from version 0 had compatibility with Edge, with Cloudflare workers, but it was all polyfills. With close collaboration with Cloudflare team, we made a version 2 of it, and we made it much better. We will explain later. Also, we are in the process of making every package ESM only to make install size less, and it's so far showing so many good results. Like I said, Nitro on the edge is one of the most important topics for us because we want to make sure your code works exactly the same way it works in Node that works in the cloud and in the edge platforms. If you haven't heard about edge workers, they are like another different way of making servers with JavaScript. They are using the same JavaScript V8 engine runtime, but they are not Node.js. If the runtime is not Node.js, it means that you don't have features from Node.js, like buffer, like Node crypto, like different things that, like async context, for example. They are not available there. So with 0 version of Nitro and Nux version 3, we had to make a compatibility layer. We made unenv. Unenv is basically a toolset, a collection of polyfills, quality polyfills that we extracted from different places. We made them nice. And they just make sure that your code works. You can even deploy your current project to a service work in your browser. It just works. With unenv version 2, we took a lot of effort, months, to rewrite the whole library, not only as polyfills, but compatible and valid ESM modules. It was crucial for us to make sure that we can have a clear module graph. Why? We will see soon. First, like when cloud providers was introduced, like when Edge platform was introduced, they was not thinking about Node.js. But very soon they realized we need Node.js. We can't just say Node.js is a different thing. And if you want to use Cloudflare workers, for example, you have to forget about it. So based on the customer feedback, they eventually started to add more and more native and built-in features in it. Before, Nitro was compatible with Cloudflare workers because we had 100% coverage of polyfills. But over the time, there was more native features, and there was features that we could never polyfill. For example, socket connections. If you want to connect to a database like MongoDB, you want to use a package like MySQL connector, you need a socket connection. And they had to be natively implemented in Cloudflare workers. But the problem is that it's shadowing. Like, we could either choose polyfill, or we could choose a native one. What if we want both? What if we want these natives from the green sides? We want to fill all the red ones, and we want to mix the ones. So, for example, crypto is missing some exports. We want to fill them. We have to merge them. So we started to think about it. The main thing for making this possible was that we had to be ESM compatible. We had to be full ESM. So we could merge these modules graphs together. We could merge exports together. And this is what we did with Unam version 2 and Nitro 2.11. We introduced a feature called hybrid Node.js compatibility. With hybrid Node.js compatibility, we have best of the both worlds. We have 100% coverage still with all the polyfills from Unam for Node.js compat, and everything that is available in the runtime natively, it's mixed. So the bundle size is smaller, the performance is much faster, and we have things that could never happen before. For example, we could connect to MySQL and MongoDB now. It was one of the fundamental issues that we had before. You can see more platform compatibility from different edge providers also here. And big shout out to Dino Deploy guys. They made probably the best compatibility for edge. This is also one of the big things. You might be wondering why Nitro version 3 is taking time. And I have to explain it with some examples. Here is a simple example to, not Siri, I don't like you. This is how you create a normal server in Node.js. And it was normal for a long time, for years, in fact, because Node.js was the only solution. If you want to deploy your, if you want to create a server application with JavaScript, you have to use Node.js. But more runtimes came, Dino. With Dino, it's different. In Dino, you have to use dino.serve. And despite note that you have to call an end function to respond, you have to now get a request that is the web request object, and there is a strange second one that if you want, for example, to get a remote IP address. OK, why not? And others introduced Bun. Bun said, OK, we are also web compatible. We have a request, which supposedly a standard web request, and a strange server, which is my server, and then you could call it to get your IP address, for example. You know, they are completely different. Node.js was for its own. It has its own server API. Dino and Bun are similar. They have standard requests, but there are slight differences. And Cloudflare workers, of course. It's also different. For example, there was a need for injecting env. There's different way of accessing requests, and there are different formats. So coming back to Nitro, our goal was to make sure there is no difference. We have to make them exactly the same. But how we make them the same? That's the question. We already made it, but how we can make it the same? Before that, let's compare these two. Like, which one is better, in fact, by the way? Is Node better, or they are better, or they are the same? There are two different ways. This is the Node.js style. In Node.js style, you have an incoming message and a server response. This is the way that you write your server using Express, using Node.js, using Connect, using Koa, or different ways. There are different syntax triggers around it, but that's the underlying thing. And the other way is that the thing that new runtimes introduced is completely different. Why? Because despite the first one that gives you a response that says, OK, call the response when you are ready, this here, we get a request, and we are supposed to return a value, just like a normal function, which is a huge difference. The first one is like an event-based system. The second one is a normal function. You get a request, you process it, and you return a value. It doesn't have side effects. Well, the good thing about the first one is that it's compatible with Node.js. Node.js was made around this to be server for JS. It's really performant because it's event-driven. You are in control. Nothing is blocked. There are huge problems with it, in fact. One of them is that imagine inside that code, you can call other middleware, and other middleware can call other functions. And any function, any place in your application can terminate a request. And you probably saw this if you are developing a server, like headers already sent, requests already sent. Some function could just do it implicitly. And there is no way to reason about it, because You have to find a place that is sending headers or ending the request inside. And with every big project over years, there is come legacy and this overhead of baggage of this. So there are multiple ways to do things inside Node with request and response. And there are diversions. For example, if you are using Express, there is rest.json to respond to JSON, but it's not built in Node. So if you are using a library that is depending on it, you are forced to use Express. You can't use any different library, which is a huge downside. And also, it's hard to test. The only way that you can test this is that you actually run a server. There are mocking libraries that they mock the interface request and response, but they are not exactly the server. Let's come back to the other one. First, there is Dino, Bon, and whole lots of more edge platforms that support and adopted this format. This format is less performant, to be fair, because that standard request and response was designed for web, not for the servers, and that's a valid criticism. Something really perfect about it, and that's really beneficial for Nitro to consider migrating, is that they are explicit. You see, here you cannot see like how an error could even happen. In fact, there is no way to find it out. If it's async, there is no way. And that's why frameworks was invented, to just make sure and put things around it to make sure support. But here, it's super clear. A function that either resolves to a value or rejects and throws an error. It's really, really easy to reason about by users and also frameworks. And it's relatively new because it's designed based on web APIs. There are subtle diversions as we saw in Dino and Bond and different runtimes, but they can be solved. And there is a whole working group working on making them standards of web for servers. So there are trade-offs. Node.js is stable, good stable. It has some of its downsides. This one also has a little bit downsides that we will try to cover, but it's really the future. It's making things much more better for us to imagine in the future for Nitro. And we introduced a package, as you can imagine, to unify them all, ServerX. ServerX is just one package to rule them out. This code, similar to Nitro, it's just one library, few kilobytes. You write this, it works everywhere. Node.js doesn't support it, but we add the support. So if you use it in Node, it just works. Use it in Bon, it's natively using Bon. If you use Clover Workers, it tries to understand the environment and listen to it. It just works. And that's the most important thing for us. We wanted something to be same and work everywhere. We tried hard, a lot hard, to make performance overhead on Node.js almost zero. So if we migrate from Node style to web style, we do not impact performance overhead. It's not a framework. There are so many frameworks that do this, like Hono, for example. It has adapters for it, but ServerX is not a framework. It's just a unification layer that we will adopt everywhere in the ecosystem. And if you remember from Dino and Bon examples, there are differences, like additions to the request object. It's not nice. There is no types for it. You have to install different types for different runtimes to make sure that they are working. But we don't want that for Nux users. If you're using Nux, you have one request. You should have types for it. And it should be exactly the same. So ServerX adds some namespace extensions to the request, and they are properly typed from one place. And you can conditionally check them. Like if you are using Cloudflare environment, you have some context, but it's fully typed. And the same interface also is available in different platforms. Some examples are remote address, for example. If you remember the examples, there was different ways to do it, but here is just one, and there is some namespaces behind it. This was really not easy to make it fast, because Node.js was not designed for it. And we tried to make it really perfect. It's almost, that's a normal Node.js application with the traditional server. And we try to make the performance as close as possible to the native. As you can see, there are other approaches, like Hono, for example. How Hono make it fast? They try to patch the globals of Node. So you have a request in Node that is usable for making the actual fetch call. And by patching it, yeah, you can make it faster. Or you can not and do some internal extensions and make it a little bit faster. or you can do less modifications, or you can be like remixed and make it somehow, I don't know how that's so. But anyway, this is what we could achieve. And this was the point that I was confident, yes, now is the time that we can universally adopt a format that is futuristic. And we hope that Node.js sometime natively supports it. We will match the performance, not maybe even faster if it's natively implemented. But this is the point that we are confident we can move forward. And as you can imagine, H3 version 2 is also joining the party. So very soon, we will release H3 version 2 that is completely rewritten with different considerations. Here is an example H3 version 1 application. It's also compatible with the web APIs, by the way. So from the first version, we make sure that it's compatible. You can define an event handler. In H3 version 1, you have to create an explicit router, and you have to mount it. It was more similar to what an Express application looks like. And you could use a converter to web event handler that internally uses onenv to emulate the network layer of Node.js. A lot of things going inside it. It's still fast, but you can say it's not perfect. It's not something futuristic. So 5 years ago or so, or when we wanted to design something like this, we had to make a solution. And Node.js was the dominant. Node.js was the default server. Now it's changing everything. There are Dino, Bon, and different cloud platforms that they need the web API. So we needed to make it different. And yeah, there's also not a way to listen. Like this code I wrote, it's just for Node.js. If you want to listen on Bon, it's different. If you want to work with cloud workers, it's different. So Nitro has internal presets that hides away this complexity. But there is complexity and a lot of things behind. Nitro version 2 is fully backward compatible. In fact, exactly the same code works in Nitro version in H3 version 2. So there are no breaking changes. There are slight behavior changes, but no breaking changes. The router and app, that's exactly the same code. The router app and app are merged. It's also much faster. We will see soon in the benchmarks. You don't need to make differences for listening because server X is exposed from H3. You just call serve. It's working. There's built-in app.fetch. That is really important, not just for performance, but for testing. If you want to test this application, you don't need to run a mocking server or mock the request and response. You just use a function called fetch. You fetch any endpoint you want in end-to-end testing. You get the response and get it. You don't need to listen to the server. It makes testing and CI much faster and stable. And it also made us able to do some benchmarks to improve the internal performance. We will see soon. That's the gist. We want something to be fast, backward compatible, and better for everyone. The only downside is that, yeah, we are not emulating Node anymore. So if you are in Cloud Workers, you don't have event.node, which it's, I think, a good trade-off because that was not the right thing to do, and we was already communicating users to not do it. H3 version 2 migration should be easy because everything is backward compatible. The only thing that you have to do is that instead of doing this implicit send, which was based on Node.js concepts, you have to return a response, or you can return a string or whatever you like. Same for errors. You have to throw errors instead of indirectly handling them. All the utils are fully compatible. Internally, they are migrated from Node APIs to universal APIs. You can now enjoy the standard base for event request.json, for example, or form data or whatever. You still have some utilities. Some of them are faster than web standards, like useQuery, but it's a trade-off that you can choose. We have both. And we also have an addition for event.response, which is a response init that you can use it to prepare the response. And we still have compatibility for Node, but only in Node, not emulating it anymore. And probably the biggest breaking change is about router, but if you are using Nux or Nitro, you don't have to worry, because Nitro handles this migration behind the scenes. Benchmark time. My talk is taking a little bit longer, and I wanted to have some disclosures before sharing it. It's months I knew about like how fast we are. I still didn't publish the benchmarks because, well, to be honest, they are like internal tools. They are tools that we make to make sure that we don't have internal flows. We can make sure there is no bottleneck in this application. Sadly, it's used in market. Like essentially every framework now that is comparable with H3 is using these as metrics. So we have to share these metrics at some point to just say we are good. But just rest assured and just use whatever you like. And if we have a chance to support more frameworks like Hono inside Nitro, we will do it differently. It's actually no difference at all what is faster. Yes, it matters to be faster, but you have to make sure that your code is faster. We have to make sure that there are best practices to make your code faster. We have to make the networking faster. We have to reduce the waterfall request, for example. It shouldn't be about the underlying framework. The difference we will see is a matter of nanoseconds. Yes, if we multiply it by like millions of times, you can have a chart that say RPS, requests per second, is higher. It's not a matter. OK, here we go. These are the benchmarks. You can see H3 version 1 was slowest amongst them. Now it's fastest among them. The difference is in matter of microseconds here. And we took a different testing strategy because, as you saw, the web handlers are a different format. We don't need to run a whole server, which adds regression and uncertainty. We just test it as a function, and we make sure this function is fast as it can be. That's all a framework is. A framework is a function that adds convention. And we try to pinpoint the issues. We try to bypass some limitations of web standards. For example, parsing URL is slow. Parsing query parameters using URL parameters is slow. We take some fast paths to make it fast. And it got faster. Yes, in paper. You can see benchmarks. You can see like H3 version 2 is the fastest framework in the web. In fact, it was. When we introduced the initial version of H3, it was fastest before all the competitors was coming. And this is, again, fastest. But again, it's nothing that you should be worried about. It's something that we can be rest assuring that the bottleneck is not the framework. Bottleneck is something else. There was some new metrics that, interestingly, some frameworks don't even take attention about. You can see the difference between Elysia and H3. It's microsecond against nanoseconds. And it's really important. If you want to run your application on serverless platforms, on edge platforms, cold start matters. And cold starts means faster app initialization. Your app, after initializing, it can take like 1 second and then fast. But we want it to be H3, to be fast, also to be started like dozens of times, because there's cold start. So these are the new metrics that I didn't saw in other benchmarks, and it was interesting that we could make it this fast. It's magnitude of faster than other competitors. And the last thing is bundle size. Also, bundle size matters because, again, if you want to deploy to edge platforms, if you want to make small applications, we don't need a whole big framework that we probably are not even using its features. So H3 was like this. That 26 kilobyte was including all the emulation and on polyfills. It was 26 kilobytes, still small, because we had this concept of composable utils. Now it is, I think, almost half. You can just compare with other frameworks because, like Elysia, for example, has a template compilation. Yes, if you run an Elysia application in a server, it can be fastest. It can be really fast. But at what cost? If you read the internal code of H3 and compare it with some of them, H3 is dummy by design. It's super simple. It's not rocket science. And yeah, we could be faster if we do some hacks. It's not. It's just plain simple code. And the same thing happened with our HTTP router. HTTP router is used in the HTTP framework, H3 framework, but also we use it for route rules. You have in Nux, for example. And the previous implementation was radix tree, which, as you can imagine, it's radix tree, like a prefix tree. And it was fast. It was relatively fast. It was not hacky. It was not depending on the platform features and optimizations like regexes. But it had some limitations. More than performance, it was more for making it compatible and more efficient. So we migrated to a new library called route tree, which is in AnJS again. And it's magnificently smaller. It's super fast. You can see how much is the difference between previous one. And it is consistent. Like, for example, Hono. Hono has a router called the Smart. What is a Smart router? Basically, it's like if you add few routes, we use a simple regex matcher. If it's more complex, we switch to something completely different to be still fast. And that trade-off means that the last one is just bundle size, because they have to bundle 2 different routers to just be fast. But we didn't want to do that. We didn't want to be smart. Actually, I think in this level, this low level, we have to be dummy. And if you read the router implementation, it's a really dummy implementation. And it's compatible, it has all the features, it's the smallest and it's fastest. I think it's really what matters here. And it's more consistent between different runtimes as well, because many of the optimizations that some frameworks do is to make it faster on Bond, for example, or on Node. But we want it to be fast on all platforms. Roadmap to Nitro version 3. I know many people are waiting for Nux version 4, and it took, I think, 1 year of delay. I'm so sorry I was saying this all the time with Nux team. We needed to make sure we have a foundation that is strong, that we can keep on going on. We can make sure everything is fast, we can be future compatible, and it involved Nitro. And Nitro was one of the reasons that Nux was delayed. But I'm super proud that we are doing it. It's happening within a month, and everything is almost ready. First, we are renaming Nitro package to Nitro because for some reason Nitro package was used and unused. So it's unblocked. We are renaming it. We made mirror packages so the migration would be smoother. Nitro Canvas is ready. If you are brave enough, you can try it. There is no documentation updates yet. We will soon update it. The compatibility date for presets are updated, so we removed the legacy code. The model is smaller. The goal is to have minimal breaking changes or no breaking changes. Everything is internal. We make sure internal is updated. Basically, whole rewrites like onenv and h3 and everything, but the code that you write is not different. We recently implemented experimental roll-down support, which is going to replace the roll-up bundler of Nitro version 3. It's going to be much faster, but that's not it. We're also thinking about supporting Vite version 6 environment API as an official starter. So if you're having a Vite project, you can just add Nitro as a plugin to it. It just works like full stack application. And we are almost close to make it happen. Docs and migration guide are in process. Maybe in a few days, matter of few days, they will be published. H3 version 2 migration for Nitro is also in progress. We want to make sure there are no breaking changes and everything is inside. So that's also one part. We will run ecosystem CI on Nux version 4 to make sure wider ecosystem, although is not much affected, we don't have a drastic breaking changes. We try to minimize them or document them. And I hope ETA to be almost a month, because every puzzle piece is finally ready. Thank you so much, and sorry for taking a lot of your time.